Saxon Algebra 2, Lesson 106. Our topic is three systems of equations, and we're going to level up a bit on these, and I will show you what's new and different. We've done these before. We have a system of three equations, and we have three variables, but here's what's different this time. There are holes. We have x variables, we have y variables, and we have z variables, but each equation does not have all three letters. They're a mix-up, and this should come all the way down. Each equation only has two of the three variables plus a constant. One variable is missing from each equation. Okay, it really helps to write these columns nicely. So what are we going to do about this? What we want to do is we want to pick any two of the variables and eliminate one of them. Let me stop saying words because it's confusing. I am going to take equation A, which is 2x plus 3y equals minus 4. And I'm going to take equation B and I'm going to multiply it times minus 2. And that will be minus 2x plus 4z equals 6. All right, I multiplied everything by 2. Now, when I add them, I will have 3y plus 4z equals 2, and these two variables are the same two variables in C, which I have not used yet. So I'm going to bring C down, and that is 2y minus z equals minus 6. And I'm going to multiply this one times 4. And I'm going to call this A and B because those are the two that are combined there. So I'm going to multiply this one. Ooh, I did that wrong. No. I'm going to multiply this one by 4 because then my z's will offset. So this will become 8y minus 4z equals minus 24. I gently squiggle this out, and I get 11y cancels equals negative 22. I like it, John, I like it. Y equals negative 2. Beautiful. Now all we have to do is back into some of these other equations. Let's do this one for, oh no, I can't do this one because I don't have x or z. I have to choose one of the ones where I have y. Let's choose this one, and I'll use another piece of paper so I don't have to turn the page. We know that y equals minus 2. So I'll use this one. 2x plus 3 times minus 2 equals minus 4. This is minus 6, so I'm going to add 6 to both sides. 2x equals 2, so that means x equals 1, right? All right, x equals 1. And then we need to solve for z. I'll choose this one. X, which is equal to 1, right? So that will be 1 minus 2z equals minus 3. So I will subtract 1. Minus 2z equals minus 4. Divide by minus 2. And I get z equals positive 2. Z equals positive 2. And so then my final answer is, I can write it as an ordered triple, right? 1 minus 2, positive 2. Put it in parentheses. We need a three-dimensional checkerboard game to graph that, like they play on Star Trek Next Generation, if you're into that sort of thing. All right, so when we have these, there's lots of ways to do them. I chose one way. I tend to work from top to bottom if I see easy ways to cancel them out. But really, it's whatever jumps into your brain. There's just one more of these. So let's take it on. Example 106.2. And again, when we write it down, the trick is to preserve the 3 columns so we can easily see what we've got. 3y minus 2z equals minus 12. 2x minus 3z equals minus 5. And x minus 2y equals 6. That's in the wrong place. Okay, I'm going to start by, I think I'll offset these against each other. So here's my starting. And now what I'm going to do is I'm going to multiply a times 2, and I'm going to multiply 3 times c, and that will get me 6y and negative 6y. So 2 times a is 6y minus 4z equals minus 24, and 3 times c is 3x minus 6y equals 18. I add them, okay? And that's what, this caught my attention because they had opposite signs, all right? So that's why I decided to offset those first. This cancels. 3x minus 4z equals negative 6. Now I pull in the equation that I haven't used yet, which is b, and I'm going to look at it and compare it, and I see, I'll put them together. 2x minus 3z equals minus 5. And this is now 2a plus 3c. That's how I got this line. So what should I do? I think I'm going to have to multiply this one times 2 again to get 6x, and I'll multiply this one by minus 3 to get minus 6. So here we go again. Draw the line. This will become 6x minus 8x equals minus 12. It's multiplying all of those by positive 2, and now we multiply this row by negative 3. We'll get negative 6x plus 9z. Oh, this should be a z. My bad. Negative 3 times negative 3 is positive 9z, and then this will equal plus 15. Those cancel. Ooh, I love when this comes out. It just is z equals 3. Cute, right? Now we have to find x and y. Let me get my calculation sheet again. Let's plug z into this one. So it's fold away. Three y minus 2 times z equals 3 equals negative 12. This is negative 6, so we're going to add 6 to both sides. 3y equals negative 6. Y equals negative 2. And then we need to do one more I'm running out of space on my paper. My overflow paper. Let's do this one. X minus 2y, and y we said was minus 2, equals 6. This is plus 4, so I'm going to have to subtract 4, aren't I? X equals 2. So my final answer is an ordered triple of 2, negative 2, positive 3. All right? That's the right answer. Yay. The trick to these is just looking for interesting combinations that you'd like to offset. Pick any two, offset them. I could have just as easily multiplied this one by minus 2. That would have worked as well. But what I like about this example is it shows you, do it however you want, do it whatever you see. Just look for two that offset each other. I chose these because of the plus minus relationship. I had to change both of them, didn't I? Right? I had to multiply to make term 6s. This one I could have just multiplied by minus 2. So that would have been a great idea too. And over here, I could have multiplied this one by negative 3 and 2, and I would have gotten 6 and negative 6. So the good news is once you squish 2 together, that will have the same variables as the third, and that's kind of fun. All right, that's all there is to lesson 106. I hope it is a joyful lesson for you. I'm way behind. Look, we're already halfway through week 28. Man, we're good. Okay, that's all. Goodbye.